If you're watching this video, thank you for your interest in the CBDB project. As you may already know, the China Biographical Database is a freely accessible relational database with biographical information currently about 530,000 individuals in Chinese history, primarily through the 7th through the 19th centuries. In this series of videos, I will demonstrate how to make use of the powerful database to investigate historical questions through the CBDB Access query system. After you follow the guidelines on the website and then download the Microsoft Access forms, open the main form through Microsoft Access, and you'll see all of those query methods that we've developed. And we will produce detailed step-by-step video tutorials with examples to demonstrate how to perform each and every query here that you see. But in the first video, I'd like to highlight one of the most powerful ways of using the CBDB data, which is for social network analysis, which is the Query Social Networks tab here. I want to preface this series of videos with a rather intricate and nuanced problem and help you get a taste of what kind of historical questions the database provides insight into. In the future videos, we will go over each query sequentially through basic examples to help you get there step by step. So today we're looking at a specific question, as we promised. It is the question of the new policies or the Wang Anshi reforms. The new policies refer to a series of reforms initiated by the Northern Song Dynasty politician Wang Anshi when he served as minister under the Emperor Shenzong from 1069 to 1076. His reform measures were highly controversial, winning enthusiastic support from some people and also hurting the interests of several different social groups. So there are distinct pro and anti-Wang Anshi or pro and anti-new policies parties formed, spearheaded by two figures, the reformists led by Wang Anshi and also the conservatives led by Sima Guang. To complicate this picture of political polarization, we might ask a series of questions. The main question being, what are the social networks of these two political enemies, both inside and outside the realm of politics? And some sub-questions we might want to look at, for example, are how do the networks overlap? And what are the middle groups in between these two social networks of those two political leaders who are enemies? And also outside of the realm of politics, are there any intellectual attacks across the two groups? Any writing exchanges, engagements, any friendship, any sort of other social relationships that would allow us to complicate the picture? And also, where is the geographical distribution of people supporting those two parties? Do supporters of one leader come from a certain region, but supporters of another leader come from another region? Is there any sort of pattern in the geographical distribution? Okay, so now let's figure out how to actually do this. Let us go to the CBDB Access form. We open this main form named CBDB User. And here we can see all of those queries available here. And we're specifically looking at query social networks today for this specific historical question. And just a little bit more about what query social networks does. Basically, it is a tool that can help us get a more nuanced understanding of the relationship in various aspects between two groups. And it allows the user to explore social networks defined both by kinship ties and other forms of social relations. The query, the way it works is that it loops over the people that the targeted person or persons know, and it outputs those who are socially connected with the targeted person or persons, either directly or indirectly. So when we clicked on query social networks, you can see a full screen of all those variables. And what I'm going to do now is to explain each and every variable so that you know exactly what to choose. So first, intuitively, we need to enter the person, basically whose social network we're curious about, right? In this case, the targeted person, actually targeted persons should be Wang Anshi and Sima Guang, those two political leaders spearheading the new policy party and the anti-new policy party. So there are three options for us to choose a person. The first option is the most forward one is to just select a person. But we can just put in their name, for example, Wang Anshi, and search. And then here we go. His name will come up and then we click select. And now we see his name here already selected as a targeted person. But a drawback of using select person button is that it only allows us to enter one person for each query. But obviously for this specific question, we need two people, Wang Shi and Sima Guang. So there's not a way for us to do it through select person. So we have two other options left. One is import people and another is recall person IDs. So recall person IDs, it's basically using the result of another query in order to use that prior result to query again. So we recall the stored person IDs from the prior query and then recall those persons and then query them based on some different criteria. Now we're not gonna worry about like nested queries, so we're not using this. We just now know these two people and we're gonna import them. And the way to import the two people is no longer just by putting their names in, but instead we need to find their person IDs. The way import people works is that it will take some sort of file that you can upload to it. And the requirement for the file is that it should be a TXT file and it should include the person ID, just plain text, just the person ID, one person ID in a row, nothing else. So now what we need to do is that we need to get the person IDs of those two people, Wang Anshi and Sima Guang. And there are several ways of doing it. One of the ways, simple ways, is that we just go back to the main form and click on the first one, look up data on an individual. And it's just a simple, quick way of trying to find the person ID. We can enter Wang Anshi here, we search, and it's just very straightforward. We see the person ID here. By the way, a person ID is an identification system that each and every individual recorded in the CBDB database has. Each and every individual in the database has a unique person ID that helps us to basically locate them. It's something that's like their unique social security number, we might say. So here we copy and paste this. We create a text file and copy and paste this. And we're going to find the next one. We look up data. We input Sima Guang, the next person. We search. Okay, and this is his ID. We copy and paste. Okay, so these are the two people. We already have this TXT file ready, and then I'm gonna save it to my desktop. I'm gonna name it as Wang Anshi Sima Guang initials. I save. Okay, so this is ready. Here we go. We see it here, and then we go back to the query social networks, and then we can import people, and we import this file from the desktop. Okay, here we go. Okay, we will see here it says imported list. It means that it is successfully uploaded, and now we can utilize it as like the targeted person. Okay, so the next step is to select the places, basically to filter the location, the area for which one wants to study the social networks. Actually, for the person and place, those are two parallel starting points. You can either start with the person and leave the place blank, or you can start with the place and then leave the person blank. Or you can do both, which we'll explain later. And in this case, we just care about Wanshi and Sima Guang. We actually do not care that much about places, so we can just leave it blank. But I'm gonna explain it anyways, just in case the problems that the questions that you have on your mind have something to do with places. So by the same logic, one can select a place or import a list of places, but in lieu of listing the person IDs and the import people button for import places, for the TXT file, we need to list the places address IDs. Okay, and for select a person, as for select a place, excuse me, we just need to enter on the name of the place, and then we select it. For example, we can look for specific social relationships formed in the place Kaifeng in the Song Dynasty. And then we will see it here, and then we can select it. Okay, and here we go, it's selected. But in this case, we're just gonna use all the places, so I just unclicked it. But I want to explain that what it does, the select place, is that it locates people with a connection to the specified place to be queried. And unless one clicks on the restrict to place button, you can see here, we still leave the Kaifeng on. Let me enter it again. And select it. You can see you can either select or deselect restrict to place. And what it does, this checkbox, what it does is that while CBDB is looping for the people, the selection of a place or list of places only influences the first step of locating an initial group of people around whom to build a social network. But if you click restricted places, all the people in the social network will be restricted to the specific place. So it depends on if you want more restriction or you only want the first layer of looping to be restricted to this place. So, but I also okay, so we do not need anything here. And I also promised to explain what it means to have both person and place selected. Basically, what it means is that it looks for people from the specified place who had connections to the selected person or group of people that match the categories of the association specified for the search. So basically, it has like double criteria that limits the people we get. Okay, so that is it for select places, and we just leave it blank. Don't think about it for our specific case. And we move on to our next step. So, okay, the third step is to limit the time. We can see the time frame here is basically controlled by these three. Now we're in the no dates mood. We just do not care about the dates. And we also can use index years, or we can use dynasties. So for the index years, you simply fill in the beginning and ending years for the index years of the people to be considered for the search. So I want to explain what index years mean in CBDB. Basically, it has its name because it's an artificial date estimated by us based on a series of assumptions. Instead of a date, an actual accurate date directly pulled from historical records. So an index year basically it is some for example, we know of a person's the year in which a person died in historical records, and then we basically calculate the relative age of him and then subtract that from his death year, and now we have an index year of this person. So index year is the birth birth year of a person that is an artificial date calculated based on some assumptions, either their death year or like the year they entered the royal examination, or some sort of like important landmarks of their life that we know the year of, but we do not know their specific date of birth or year of birth. So that is an artificial date. That is it. And so the reason why we add a lot of index years to people is that we need to give more people in a database a temporal attribute so that they could be searchable when we filter the time. Okay, so now we want to limit the years for those two for the specific query, and what we are going to do is 1,000 and 1086. So 1086 is the time when both guys, Wang Shi and Sima Guang, died. And 1000 is an earlier year, basically like relatively the same time when those two guys were born. So we want to cover all the person who were born at the same time with those two guys, and also the person as young as someone who was born on the same year of their death. So we want to cover a reasonable round in terms of time. So any of the person who was born during the entire lifespan of those two political figures, we want to count them all. Okay, so this is the index years, this is the time. We can also use dynasties, which is just very, very straightforward. For example, we use like Song Dynasty. We can select Song from here, which is Song. We just select. We do not need dynasty here. We just need index years. But if we want to just limit it to a more general dynasty, like several hundreds of years, you can just use dynasties. You do not need that specific years. Okay, so now we figured out the person, the place, and also the time period. Next, we need to select two very important metrics: the node distance and the maximum number of iterations. So basically, there are the two matrices here. These have something to do with the fundamental logic behind how the social network runs. I'm going to briefly explain it, although we don't need to change a lot of it. Okay, just to show you an example, think of a social network as a tree and each individual in the network as a node. The node distance that we just mentioned basically means the number of links between any person in a network and the people you put in the select people as the targeted person or persons. So if we choose Wang here as the targeted person, and what we mean by node distance 1 is that basically anyone directly connected to Wang. In this case, it will be Su and Li. So Su and Li were the people who have node distance 1 towards Wang. And for node distance equals 2, that basically means like friends, or basically like mom's mom, all those sort of relationship. So friends, anyone connected to Wang through someone else. We can see here Liu is 1, right? And also Cai is 1, right? And also Zhang is 1, right? So, oh, sorry, I did not mention that Qing was also someone who is connected to Wang with a node distance of 1. So, in this case, Liu, Cai, and Zhang, these are all people who have node distance 1 with Wang. So you can get a sense of what node distance means in terms of social network as a tree and each individual as nodes. So basically, how many links, how many edges, like each line here represents an edge, how many edges there are between this person in a network and the targeted person. Now that we understand what node distance means, I want to clarify several points, which is if one selects a person to start with, here just now select person, then all the distances are measured from that specific targeted person. But if one starts with a list of people, then all the people on that list serve as starting points. So for here, both Wang Shi and Sima Guang will serve as the targeted people, like equally. Anyone with direct relationship with either one of them will be counted as node distance 1. And also, if we start with a place or list of places, then the people initially identified as associated with that place or those places serve as starting points, from whom we can calculate the node distance between people in a network and them. Okay, so we need to note that the number of people found by the search procedure can grow exponentially with the increase in the node distance. We want to make sure that the network won't always keep expanding and more irrelevant people just keep showing up in the network. We don't want that to happen. So we usually limit the max node distance to usually below 3. And in this case, we want to directly look at people who are directly connected to Sima Guang and Wang Shi. So we set it to 1. We do not want it to be extremely huge. We want to limit the scope of the result. Okay, and that is it for max node distance. And then we have max loop, which is also a tricky concept to deal with. Basically, it counts how many times the query iterates through the list of people, basically iterating to make sure that we don't miss any people in a network. It's more on the side of the algorithm for the social network, and it helps with the precision, but it is not a big deal for us to limit. So because a very huge loop count can make the system very slow, we usually just leave it as the default, which is 10. We just do not touch it that much. Okay, so now we have all of those metrics set up. Next, we're gonna select what kind of social network we want to look at. So here we can see all of those. There are so many different kinds of networks, which is one of the powerful things about social network query. It allows us to query so many different sorts of relationships. First, I sort of want to deselect everything and just want to go through what are the categories and what we really want. So there are a lot of large groups of categories, including friendship, family relation, finance, medicine, military, scholarship, including all of those subcategories, politics, writings. In this specific case, what we want to include is let's say friendship. We want to see what are the like friendship between those political enemies, like outside the real politics, what their personal friendships are. So we include that. We do not want family, we do not want religion, no finance, no medicine, no military. We do want to look at a lot about scholarship. What are their like scholarly engagement. We do want to look at politics, but we do not want to look at opposition. We want to look at their connection or with each other. And also we want to look at writings. So one way is that we just select all of those, but we can also sort of play with it and then like deselect some of them depending on our specific research needs. But now I'm just gonna start with all of those metrics and just include all of them. And I do not want to include kin. We want to find, because the final step we need to do is select types of kin and also to select female and male. We do not want kin here. We do not want any family member, as we did not enter here. And we do want to enter both genders, female and male people in this network. So we just click them. Okay, I think we're ready to go. Yes, I think we're ready to go. We can just run the query. We have the person, we have the place. We do not need the place actually. We have the dates. We have the max node distance. We have the loop. We have sorts of types of relations we want to look at. Everything seems all set. Okay, so we just run the query. Where we run the query is just to click on this button. And then presumably it has finished running the query, and what we need to look at is the three different output forms. So there are three different output forms, and they each represent the data we get in slightly different ways. The one in the middle, people in the social network, just obviously, that shows people. So each of them is a different people. Each a different person. There's no repetition here. Basically who are involved in the network, while the first and the third tabs, social network relationship and relations aggregated social relations, they show how people are involved in the network. Basically, each record entry is a relationship between the two people. And for the aggregated social relations tab, it just has one record for each pair of people that gives the number of relations between them. So, for example, we can see here, so they're based on a specific relationship. And for example, we can see between Chao Buzhi and Fan Chunren, their relationship is multiple associations emerged from not that helpful, but we can also have some very specific examples. One composed a sacrificial prayer written for another person. Chao Buzhi did that for Ouyang Xiu. And we can see that obviously Chao Buzhi appears so many times, other than for the social people in social network. Chao Buzhi only appears once because it's organized based on person. But for here, it's based on relationship. It's relationship oriented. So there, a person can appear so many different times as long as the relationship does not repeat. And what the aggregated social relationships does is that it does not, because each relationship is double-sided, right? It does not count it twice. So basically, this is almost like half number of the relationships here, because it only counts it once. Because, for example, like I'm your friend, you're also my friend. We would be counted twice here in the social network relationship, but in the aggregated one, we only count that once. Okay, so this is how we interpret the findings, and we can see all of those peoples who are related to Wang Shi and Sima Guang, and what are their relationships among each other, and also related to Wang Shi and Sima Guang. Okay, so we can already see some interesting patterns that we dig enough into those forms. But an even more powerful way for us to analyze the results is to look at is to resort to a specific third-party model, a different model, which is called GAFI. It is a specific social network analysis model. We can directly import what we get here, import the entire network. It basically will help you visualize all the social networks. So we can import it to GAFI. I'm not going to teach GAFI here. I'm just going to show what it looks like when you import this to GAFI. So basically what we get out of the GAFI social network model, which is the software that we import the result from the CBDB query into, is this sort of a diagram preliminarily. And basically it evokes the idea we discussed earlier of a social network being depicted like a tree, and each individual is a node. Here you can see these are the nodes, the people, and like these lines are the edges indicating relationship between each other. And we can probably guess one of those larger nodes, which represents that they have so many networks connections. These are probably one of Wang Shi. Probably one of them is like Sima Guang or like some other big figures. And then we can try to get more out of this graph by trying to go to the laboratory, and then we try to sort of like mark everyone with their names. And we can truly see, yeah, this is truly Wang Shi, who has a lot of connections. We also have Sima Guang here, but we also discover so many interesting other figures, such as Huang Tingjian, Su Shi, and Ouyang Xiu. Those are all like big figures that also had very large nodes, a lot of connections, even larger than Sima Guang. We might think about why. Here is a graph simplified by filtering out those with only one connection. We just get a more like succinct form of the network. And we can see even more clearly that really Su Shi, Huang Tingqian, and Ouyang Xiu, they really do have a very strong social network, probably even at the same level with Wang Shi. Probably the other political enemy, Sima Guang, is a little bit smaller. We can explain this by the fact that probably those two people, Huang Tingjian, Su Shi, and Ouyang Xiu, they're the opponents of Wang Shi, but they have such like small in between groups between Wang Shi and Sima Guang, because this is in general a network of Wang Shi and Sima Guang, but we can see all of those other people who have very strong connections, because probably because these people are the ones whose writing were in demand at that time. Their writings mattered a lot. They're great literary figures, poets. So probably it has something to do with the writings. We selected writings as one of the criteria in our search. If we do not want to include writing, we might modify it if we do it the next time. So that kind of sort of explains. It shows that we need to understand that this is basically a network of everyone connected to Wang Shi and Sima Guang. The two poles should have been Wang Shi and Sima Guang, but we can actually see so many like in between middle groups such as Su Shi and Huang Tingjian and Ouyang Xiu that exists within the network of Wang Shi and Sima Guang, but they have a lot of strong connections with people who are also connected to one of the two figures, two political enemies, Wang Shi and Sima Guang. And we need to know that there's no person in this diagram that is not related to any of Wang Shi and Sima Guang. So any of the people who appears here must have something to do with either Wang Shi or Sima Guang. Okay, this is basically what it will look like. And then I want to show you another very powerful way to import the data that we get to another software, which is GIS. That answers our second question, which is what is the geographical distribution of the supporters and opponents to Wang Shi, like people supporting those two different parties, where they basically come from, geographically speaking. We want to see it on a map. We want to visualize this the same way as we visualize the social networking GEFI. So what we're gonna do is that we save it to GIS. Basically, what it does is that it saves the index place, like basically where each person in the network, where they're from, their index place, and they save their XY coordinates on the map. And then we will get a visual picture, like basically where they are on the map. I'm not going to teach GIS, but I am going to show what you're going to get. And basically, this is what you're going to see. And for here, we can mark the two groups separately, people related to Wang Shi and people related to Sima Guang. And we label all the people related to Sima Guang, people who support Sima Guang, with those sort of green color. And we mark people supporting Wang Shi with the red color, and we can see where Sima Guang and where Wang Shi are, where their supporters are from. We can see first for Sima Guang supporters, they're more from like the northern area, which is in line of some of existing scholarship on this topic. They basically argue that for the more conservative forests, they come from the northern part of China, and then for the reformists, the Wang Shi party, a lot of the supporters come from the southern region, and we can see if that is really the case. And by the way, the slice of the circles here, basically they they represent the number of people from this region. So like the largest one, they're like 13 to 14 people coming from this region supporting Smakwang. And for these ones, probably there's just one person coming from these areas. Okay, so these are Smakwang supporters. Let us see what Wansh's supporters look like in the map. Okay, here we go. Actually, you can see that there are a lot more supporters coming from the southeast coastal region who support Wanshi, and actually we can which is in line with the existing scholarship, and we can also try to put them together. Now we can see if we select both Sima and Wanshi, we will be able to see where both of their supporters come from. Basically, it's diagram here. We'll get a very clear sense of basically where they're from. It's very visual, geographical distribution of those people supporting those two enemies, supporting those two parties, basically. Okay, so these are a couple of ways where we can sort of import the results of this social network query to apply them to different softwares like GetFi social network models or GIS model, QGIS models, and CBDB, which a nice thing about it is that it has a direct link toward it. As long as you've installed GIS and GetFi models, you'll be able to directly import your output into it. So this is sort of the first video demonstrating how the social network query empowers research into humanistic questions, historical questions of visualizing the social networks and also identifying where the people are coming from. One thing I really, really like about it is that it's really, really visual. It can really tell you, it can visualize things, and it can show those connections in a very comprehensive way. So this is just one example, and we will please keep posted. Stay tuned, and we will update the video series to present all of those other queries in the CBDB access form. And that's it. Thank you. Thank you so much for your time. Thank you. Looking forward to see you next time.